Good evening, guys. Welcome back to section 8.3.2. Today we're going to be taking a look at the link between these factors and zeros and Polydoku and pretty much everything we've learned in chapter 8, and we're going to be putting it together so that we can take a polynomial of pretty much any degree, whether it be a fourth degree or a fifth degree or sixth degree polynomial, and actually put it into its factored form. All right. So that's kind of our goal today, is for me to show you how to do that. There's a lot going on here, so make sure you pause and rewatch if you need to make sure that you understand what's happening here. All right. So let's take a look at this first one. We're going to talk about a theorem called the integral zero theorem. All right. And it essentially says that for any polynomial that has integer coefficients, right? So like this polynomial right here is what they're talking about. It says if an integer is a zero or a root of the polynomial, then it must also be a factor. And remember, our goal is to take a polynomial that looks like this, right? This is a third degree polynomial, and we want to write it in its factored form so it looks like this, where we have the three parentheses going on here, okay? And we know how to do that for something that's like an x squared. So like if I had x squared plus 3x minus 4, like we know how to turn that into something that looks like this, but we don't know how to do that for a polynomial that is higher than a degree 2. And that's what we're going to try and accomplish today. All right. And one of the first tools that we use to do this is the graph. All right. We use a mixture of the graph and Polydoku to help us out with putting this in its factored form. So I'm going to pull up my graphing calculator, and I'm going to take my polynomial here, this x to the third minus 5x squared minus x plus 5, and I'm going to put that into y1. So hopefully you can see that here. I've already got mine entered to save time on the video, but you'll have to type that in yourself if you want to follow along. All right. And then what I'm going to do is I'm going to go ahead and hit graph, and I'll get my polynomial. This is my cubic polynomial here. And you'll notice where this thing crosses the x-axis, right? So we can see that it crosses the x-axis here at -1. So that is one of my zeros. And I'm just going to list my zeros over here. So I'm going to say I have a 0 at -1. And I'm going to go back to my graph. I have another one right here. That one's at +1. And this one is at, let's see, 1, 2, 3, 4, 5. So we have another 0 at 5. All right, and what the integral zero theorem says, if these are zeros, right, then they must also have a corresponding factor. And we've seen this before. We've actually done it in the previous sections, where we know that if we have an x-intercept at -1, then we must have a factor at x plus 1. All right. It switches the sign when we go into the parentheses. So this one is at a +1, which means I'm going to have a factor of x minus 1. And this one has a +5, so it's going to have a factor of x minus 5. And look at that. We took a third degree polynomial and we wrote it in its factored form. No need for a box or diamond, no need for a Polydoku or anything like that. We were able to simply use the graph to factor this polynomial, which is pretty cool. All right, but they're not always that simple. All right, so we're going to take a look here at this next theorem. It's called the factor theorem, and it essentially says the same thing as the integral zero theorem. It says if we have a 0, let's call it a, right, then we know we have a factor x minus a. Right, we just saw that in the previous problem. And vice versa, if we have x minus a, then we know that a is a root or 0. So for instance, if I know this factor, then I know -1 is a 0. All right, so it goes both ways. But the big reveal from this particular theorem is that if we have a factor like x plus 1, okay, then it has to divide evenly into the polynomial. So for instance, if I took this polynomial, x to the third minus 5x squared, and I divided it by x plus 1, it would divide evenly. In other words, there would be no remainder at the end. And we'll see why that is important later on, okay? So the Polydoku stuff is going to start to come in a little bit later when we deal with roots that are not exactly integers, right? So I'll show you what that looks like later. But let's just contemplate what this is saying. It says if we have a polynomial that has these particular zeros, 1, 2, and -4, then I know that the factors of the polynomial are going to look like this. I'm going to have x minus 1, x minus 2, and x plus 4. Right? So all the signs switch as they go into the parentheses. These are my factors. So whatever the polynomial is, I know that my polynomial will divide evenly by any of these three factors. That's what this thing says. All right? So put that in the back of your minds for right now. We'll see that a little bit later. And then this is some important information from the previous lessons that we need to move forward. All right? The degree of the polynomial tells us how many roots we have. So if we have a third degree polynomial, we're going to have 3 roots. If we have a fifth degree polynomial, we're going to have 5 roots. Right? Polynomials can have real roots and or complex roots. All right, so we talked about the complex numbers. We saw polynomials that have complex roots or complex zeros. Those are going to pop up here in this particular concept as well. All right, so we might run into a fourth degree polynomial that has a mixture of real roots and complex roots. All right, this can happen. We need to know how to deal with those. All right, double roots and triple roots. Remember when we talked about those in the previous lesson? Remember, if we see a double root on a graph, it counts for 2 of your real roots, but only 1 x-intercept. So we'll only see 1 x-intercept on the graph, but we'll see that bounce, right? Because remember, double roots bounce. If we see a bounce, we know that actually counts for 2 real roots. Triple roots, right? That's where we have the little inflection that looks like this, right? It kind of goes through and makes that little inflection piece right there. We know that's a triple root and it counts for 3 of the real roots, but again, only 1 x-intercept, right? And this is another key piece of information. We talked about this in one of the discussions in the earlier lessons, but if there is a complex root, it will always come in pairs. There will always be either 2 or 4 or 6 complex roots. They will never have there will never be a polynomial that only has 1 complex root. It has to have 2 or 4 or 6, so forth and so on. All right, so keep these things in mind. They're all very valuable clues. All right, so we're going to take a look at our first polynomial here. We'll call it p of x. It is a 4th degree polynomial. And the first thing that we're going to do when we run into a problem like this, because remember, our goal here is to write this thing in its factored form, right? So it says look at the graph or table and determine the linear factors of the polynomial. And we're going to write this thing in its factored form and find its roots, okay? So to do that, the first thing we have to do is always look at the graphs. Let's find whatever zeros we can from the graph, okay? I'm going to go to my calculator. And I'm going to go to y equals. You'll notice I already have my polynomial entered here into y2. So if you want, you can follow along. Go ahead and type in p of x over here. And you can pause the video if you need to. And I'm going to go down here to y2. And I'm going to turn that graph on and take a look at what that graph looks like. So this is my 4th degree polynomial p of x. Okay. So we see 4th degree polynomial. We've got some places down here where it looks like it hits the x-axis. It's kind of hard to see. I'd like to zoom in a little bit, so I'm going to use my zoom in feature to take a closer look at those zeros or x-intercepts, right? So there's 1, 2. Wait for it to come back down here. 3 and 4. So these two actually happen really close to each other. You see it comes down here, it intercepts for the 3rd time, and then it comes back up for the 4th time, which is what we expected. We had a 4th degree polynomial. We have 4 x-intercepts, okay? So we have 4 of them. And you'll notice here in part B, now that we have looked at the graph, I want to list whatever zeros I can. This one's very clear. It happens at -1. So I'm just going to say we have a 0 at -1. And we have another one that happens right here at +2. And then you'll notice the other 2 zeros, like this one is some decimal. It's in between -1 and -2, so I don't know exactly what it is. And this one happens in between 1 and 2, so I don't know what that one is either. So it makes it a little bit difficult. I can't just pick those off of the graph, okay? So I've got to go, I'm going to start with the 2 that I know. And I would say, well, if I'm trying to write the equation of this polynomial, I could say for right now, I have f of x equals x plus 1. and x minus 2, and then there's 2 more that I don't know. I don't know what these other 2 are, okay? So you see how it got a little bit more difficult from the one on the front page, okay? So to figure out what those other 2 are, we're going to use PolyDoku. All right, so this is where the PolyDoku comes in. We're going to take one of our factors, right? We're going to take either x plus 1 or x minus 2, and we're going to divide it into this x to the 4th polynomial. Okay, so here we go. We're going to set up a PolyDoku here. So I'm going to say x plus 1. So I'm going to draw this out. See what happens here. It takes a little bit of practice to draw these out. And then the x to the 4th minus x to the 3rd minus 5x squared, that's going to get lined up down here at the bottom. So you have to recall that from our previous lessons. Okay, so x to the 4th minus x to the 3rd minus 5x squared plus 3x plus 6. All right, and I'm going to make a column here for the x to the 4th. And remember, x to the 4th will be the one that's all by itself in the upper left-hand box. And then we start working our way across, right? X times something gives me x to the 4th. Well, that is x to the 3rd. So I'm going to do x to the 3rd times 1. That gets me an x to the 3rd down here. And I'm going to create another column for my x to the 3rds. And remember, along these diagonals here, right, the x to the 3rds, all my 3rd degree terms have to add up to be -1. I have a positive 1, so I need a negative 2x to the 3rd here. That way, when I add those together, I get the negative 1x to the 3rd that I see down here. So x times something gives me negative 2x to the 3rd. Well, that's got to be negative 2x squared. And then I multiply down, so negative 2x squared times 1 is negative 2x squared. Okay, so I work my way across. I'm done with that column, so I'm going to create a column for the x squareds. And my x squareds, this diagonal right here, has to add up to -5. So I'm going to need another negative 3x squared. So then x times something gives me negative 3x squared. Well, it's got to be negative 3x. Okay. Then negative 3x times 1 is negative 3x. And we're done with that column. So I'm going to create another column. This one's for my x's. And our x's, right, this diagonal has to add up to be a positive 3. So this is going to have to be a 6. So 6x plus a negative 3x gives me positive 3x. So I'm going to need a 6 up here because 6 times x is 6x. And then 6 times 1 is 6. And that'll actually end it, right? Because I got my 6 that lines up with the last term, which is what we expected to happen. That's what it means to say that a factor divides evenly into that polynomial. It means that last number is going to line up with the last number in your polynomial. Okay? There's no remainder. There's nothing left over. All right, so when we divided those two things, this is what we got. We got x to the 3rd minus 2x squared minus 3x plus 6. I essentially took what we got in the top here, this piece. That is the result of my division. Okay, so to keep going, right? So we divided by x plus 1. We have one more factor that we know about, and that is the x minus 2 up here. So I'm going to take this x to the 3rd minus 2x squared minus 3x plus 6, and I'm going to divide it by x minus 2. Okay, so essentially what I'm doing is x to the 3rd minus 2x squared minus 3x plus 6, and I am dividing that by x minus 2. And I'm going to set up a PolyDoku to help me with that. Okay, so I'm going to put my x minus 2 along the side, just like that. There we go. I'm going to create my box. And then I'm going to take the x to the 3rd minus 2x squared minus 3x plus 6, and I'm going to put it down here along the bottom. Just like that. And I'm going to create my first column. And x to the 3rd is going to go all by itself right here. And then I'm going to start working my way down. So I need an x squared. X squared times -2 is -2x squared. And then remember that my x squareds have to add up to negative 2x squared, right? So I'm going to create my next column, and this diagonal right here has to add up to give me negative 2x squared. Well, I already have a negative 2x squared, so this is just going to be 0. Right? That way, when I add them, I get what I need. Right? So I'm going to say x times something gives me 0. Well, that's got to be a 0. And then 0 times negative 2 is just 0. Okay? And we keep on going, right? So I'm going to create my next column. This one's for the negative 3x. Okay? And right now, that's this diagonal, and I have a 0. So if I want this diagonal to add up to negative 3x, that means this has to be a negative 3x. Negative 3x plus 0 is negative 3x. So x times something gives me negative 3x. Well, that's got to be a negative 3. And then negative 3 times negative 2 is a positive 6. And that is it. Notice that my last numbers here, they line up. So we're good to go. All right, so when I divided these two things, right, I divided these two things, and this is what I got. I got x squared minus 3. All right, so I started with this 4th degree polynomial that we see right here. Okay, we divided it by x plus 1. We got this. Then I divided it again by the other factor, x minus 2, and I got this. Okay? So here's what my polynomial looks like right now. Let's check this out. This is what we're dealing with. Okay? We have our two factors, x minus 2 and x plus 1. And we were supposed to have two more factors, but right now this is what we have. We have x squared minus 3. Okay? This is going to split into two more. I'll show you how to do that here in just a sec. Okay? So we're going to take this x squared minus 3, and we're going to find our other two roots by using the quadratic formula. Right? So we want a, b, and c. Okay? So we want our a, b, and c. And I'm going to say a is 1, because that's the number in front of x squared. B is 0, because there is no x term. And c is negative 3. That's the constant on the end. And here I go. I'm going to go ahead and start my quadratic formula. We've got negative b plus or minus. We've got 0, right? Or you could say negative 0 if you want, plus or minus the square root of 0 squared minus c. 4 times 1 times negative 3. And this will be all over 2a. So that's just 2. And then we start simplifying, right? So it'll just be 0 plus or minus. 0 squared is just 0. And then you have negative 4 times 1 times negative 3. So that would just be 0 plus 12 all over 2. And then you have 0 plus or minus the square root of 12 over 2. And there's our two roots. So we could go and get a decimal value for each of those. So I could do the square root of 12 divided by 2. Pull my calculator over here. So one of them is going to be at 1.73. And then the other one is going to be negative root 12 over 2. So we'll get negative 1.73. Do that, and I'll verify that for you, right? So I would do essentially the same thing here, but we would have a negative in front of it, right, like that. And there it is. We get a negative 1.73, and those are the other two zeros. All right, so remember, this thing had two zeros in it, and so I'm going to rewrite this. This, right? I've got two factors here, and one of them is going to be x minus 1.73. The other will be x plus 1.73. Okay, and I just want to verify these on my graph real quick. So I'm going to go back to my calculator. All right, so remember our graph that we had on our calculator. Remember that we got 1.73 and negative 1.73 for, let me move this over here, for those two other zeros that we couldn't find from the graph, right? Remember, these ones were the decimal ones. I'm like, I'm not sure what those are. So if I move my cursor over there, right, to this one that was the decimal, You can kind of see, there it is. We're like right at the negative 1.73 that we got here algebraically. Then the one over here on the far right, the other decimal one that we couldn't figure out was right here, right? So again, right at about 1.73. I can't get the cursor to line up right on the 1.73 that we got from the calculation, but that's how you get those other two. All right, so it sounds like a long process. I wish there was a shorter way, but essentially you start with the graph to get the first two factors. You divide those using Polydoku into your big polynomial, and whatever's left over after you divide out all of your factors, right? That was that x squared minus 3. You either need to solve that using a quadratic formula or by setting it equal to 0 and just using algebra to solve it. Okay, we're going to see more examples of this. This is just the first one, so we're going to see more in the next video. In the next video, we'll see this next one. I'll show you how to do this one again step by step. So we'll see more of them. We're going to see some different situations where we have double roots and triple roots and things like that. We're going to also see some that have complex roots in it. So this is it. This is the culmination of chapter 8. Okay, so feeling a little overwhelmed, it's okay. Brand new. It's a big problem. Okay. All right. So tune in next time. Try the practice problems, see if you can figure those out, and good luck.